Continuing with 5, 6, and 7. Same thing that we just did, a little different stuff later on. If needed, first write the given function as a single rational expression, then factor the numerator and denominator. So we have 5x plus 5 over 3x plus 12. We can factor something out of this one, so it would be 5 on the top, which would leave us with x plus 1. We'd factor 3 out on the bottom, which would leave us with x plus 4. And that would be our answer to this first one. But none of that cancels, so it just stays like that. Now our domain, so we only care about the bottom of this, so we're looking at 3 times x plus 4 equals 0, because we want to know what's going to make it undefined. 3 equals 0, don't matter, so we'd have x plus 4 equals 0, so it would be negative 4. X cannot equal negative 4. Write it in lowest terms, so looking at this one, we can't cancel anything out. So when they say lowest terms, they're looking for something that can cancel out of it, and we can't cancel anything out of this, so it's already in its lowest terms. Let's go ahead and mark these. Locate the intercepts of the graph. So we're going to take our equation and we're going to have 0 equals 5x plus 5 over 3x plus 12. Then we're going to have y equals 5 times 0 plus 5 over 3 times 0 plus 12. So this one, when we multiply by the 3x plus 12, it would be 0. So we'd have 0 equals 5x plus 5. Subtract our 5. Negative 5 equals 5x. Negative 1 equals x. Over here, y equals 5/12. So on this one, we have an x and y intercept. So let's find that option. The graph has intercepts. The graph has y known. So the graph has x-intercepts, -1, and y-intercept, 5/12. Determine the behavior of the graph at any x-intercept. Select the correct choice below. And if necessary, fill in the answer boxes to complete your choice. So here's our function. We're looking at our zeros. And on our intercept, this -1, it has the multiplicity of 1. So since the multiplicity is 1, we're going to cross. The graph will cross at x equals -1. And we don't worry about the 0 here, this -4, because x cannot equal -4, as you remember in the domain. We will need that value later for when we're doing those intervals, but not yet. Determine the vertical asymptotes. If one exists, select the correct choice below, and if necessary, fill in the answer boxes to complete your choice. So going with our domain, and that x could not equal 4, that is because that is an asymptote. So our vertical asymptote is x equals 4. Determine the behavior on either side of the vertical asymptote. So same thing here. The multiplicity of that is 1. Since it is 1, we approach infinity on one side and negative infinity on the other. Which one says that is our next question. Infinity on one side and negative infinity on the other, but that has 2. We only have 1 vertical asymptote, so it approaches infinity on one side of the asymptote at x and negative infinity on the other. So determine the horizontal asymptote if one exists. Select the correct choice below. If necessary, fill in the answer boxes to complete your choice. So to find out, remember horizontal or oblique, we have to have our degree of our numerator and denominator, And on this one, the degree of the numerator is 1. The degree of the denominator is also 1. So we have n equals m. So I'm going to write that over here. We have n equals m. And when we have n equals m, we take the leading coefficients. So on our equation, we'd have 5x and 3x. So our leading coefficients would be 5/3. So, and it's horizontal. That means there's no oblique. Determine the points, if any, at which the graph of R intersects the horizontal or oblique asymptote if one exists. Select the correct choice below if necessary. So we're going to treat it just like a intercept, and we're going to plug in that 5/3. So we have 5/3 equals 5x plus 5 times 3x plus 12. We're divided by 3x plus 12. And I don't know why I put parentheses on this because that makes it a completely different equation. Okay. Now then, solving for this, we'd multiply that 3x plus 12 by 5/3. So 5/3 times 5 times 3 is 15, divided by 3 would be 5x. 5 times 12 is 60, divided by 3 is 20. When I go to combine my x's, cancel, and 20 does not equal 5. So it does not intersect. A graph of R intersects the horizontal and infinitely many. No, there is no point at which, because there is a horizontal asymptote, it just doesn't get intersected. So be sure you pay attention to that. Use the real zeros to the intervals, So negative infinity, and then our next value would be, we can look back. Let's see. We have -4, -1. So -4 is low. So negative infinity to -4, -4 to -1, -1 to infinity. I'm going to use -5 here. Let's use -2 here, and let's use +2 here. And we're going to plug them into, and we're not trying to solve them, we're just trying to decide if it's positive or negative. So I have 5 times -5 plus 5 over 3 times -5 plus 12. So we have -25 plus 5 over -15 plus 12. So this would have been -20 over -3. Negative divided by negative is positive. So above, I'm going to put A up here for when we go looking later. Okay. Then we have 5 times -2 plus 5. 3 times -2 plus 12, which would have been -10 plus 5, which is -5. And -6 plus 12, which would have been +6. So this would have been a negative, so it's below. Then 2, so we have 5 times 2 plus 5 over 3 times 2 plus 12. There's nothing in here that's going to make that negative. 10 plus 5 is 15. 6 plus 12 is 18. It's positive. It's above. So when we go to do our intervals, the graph is above the axis on the intervals negative infinity to -4. And it's above on -1 to infinity. And then it is below on -4 to -1. Number 6. Follow the steps for graphing a rational function to graph the function. Oh, I didn't graph this one. My bad. So then looking at this real quick before we move on, it's above negative infinity to -4. So negative infinity to -4, we're above here. And then -1 to infinity, we're above here. So there. Now I can do this one. So first thing I'm going to do, they want us to factor if possible. This is the difference of two squares that does factor. So I'd have 9 over x minus 2 times x plus 2. So my domain, the zeros of this would be 2 and -2. And then it doesn't cancel, nothing cancels in this. So it's already in its lowest terms. Locate the intercepts. So our intercepts, we'd have, can y'all see it right over there? 0 equals 9 over x squared minus 4, or y equals 9 over 0 squared minus 4. So when I do x squared minus 4 times 0, it would be 0 equals 9. That's not true. And then this would be y equals -9 over 4. So we have a y-intercept, but not an x-intercept. So I'm going to write no x here. So the graph has a y-intercept of -9 over 4. Determine the behavior of the graph at any x-intercepts. There's no x-intercepts. So there's no x-intercepts. No x-intercepts. Okay. I'm going to go ahead and write down our function 2 now. So r of x equals 9 over x squared minus 4. Determine the vertical asymptotes. If one exists, select the correct choice below. So our domain couldn't equal 2 or -2 because this is the difference of two squares. So it has 2 vertical asymptotes, with the leftmost being x equals -2 and the rightmost being x equals 2. So where the domain cannot equal, it's that asymptote where nothing can equal, or that function can't equal. Determine the behavior of the graph on either side of any vertical asymptotes. So we look at the degree, both of these, or the degree multiplicity. We look at the multiplicity of both of these zeros, and they're both 1. Since they're both 1, when we have the multiplicity of 1, it approaches infinity on one side and negative infinity on the other. So it approaches infinity on one side of the asymptote at x equals, and this is the double joint one though, because so it approaches infinity on one side of the asymptote at a negative infinity on the other. So at 2 and -2. Determine the horizontal asymptotes if one exists. Collect the correct choice below. So we have to find the degree of the numerator and the denominator. So numerator, denominator. Numerator is 0 because there's not a variable up there. Denominator would be 2. So we'd have numerator is less than the denominator. So we have the horizontal asymptote. Y equals 0. So I'll write this note on here later. So 1 at y equals 0. I'll do it now in case anyone is watching this back later and they don't have this note paper. And just remember where I'm pulling this stuff out of is our paper from 5.3 right there. So just, yeah. Since we had a horizontal, there is no oblique. Determine the points, if any, at which the graph R intersects the horizontal or oblique asymptote. If one exists, So y equals 0 on this graph, that would be in our x-intercept, but there is no x-intercept, so we will not intersect it. So there is no point at which the graph of R intersects. All right. Now then we're going to do our intervals. So we have negative infinity to -2. Then we have -2 to 2. We have 2 to infinity. So let's use -5, 0, and 5. And then we have 9 over x squared subtract 4. I'm going to scoot it up. So 9 over -5 squared subtract 4. That would have been positive 25 subtract 4, so it would have been positive, so above. Here, 9 over 0 squared subtract 4. This would have been -9/4, so negative below. Then 9 over 5 squared subtract 4. 25 subtract 4 is positive above. So writing our intervals, the graph of R is above the x-axis and below there. So we're above at -infinity to -2 and 2 to infinity. And then we're below -2 to 2. And don't use any brackets on these because the turning points, no, it's not equal to them. So we have above -infinity to -2 and 2 to infinity, and then below here, so okay, I'm checking. Factor if you can. On this one, we can factor out the bottom. You cannot factor out the top because there's no factors of 5 that add to get 1. I thought about it a long time, and then I realized I was stupid. So we have, this is the difference of 2 squares, so it factors to x minus 8 times x plus 8. But the top stays the same, so x to the 4th plus x squared plus 5 all over x subtract 8 times x plus 8. Then looking at the zeros of this for our domain, it would be 8 and -8, so it cannot equal 8 or -8. Nothing canceled out among these because this didn't factor, so it is in its lowest terms. Then we're looking for our intercepts, so go ahead and do this on this one. So we'd have 0 equals x to the 4th plus x squared plus 5 over squared subtract 64, and then we'd have y equals 0 to the 4th plus 0 squared plus 5 over 0 squared subtract 64. We'd multiply this over, so 0 equals x to the 4th plus x squared plus 5. This doesn't factor if I was to subtract my 5. And then I could try and take the square root of both sides, and when I do that, I'd be taking the square root of a negative, so it wouldn't be a real number. So no real numbers. over here, we just simplify that out and we'd be left with a negative 5/64. So no x-intercept. So the graph has a y-intercept and no x-intercept, and our y-intercept is negative 5/64. To determine the behavior of the graph P at any x-intercepts, well, there is none. Oh, y'all can't even see that. Determine the behavior of the graph at any x-intercepts. There is none, because we just did that. Determine the vertical asymptotes if one exists. So our vertical asymptotes, we reserve it back to our domain, and domain could not equal 8 or -8. So our vertical asymptotes is 8 and -8. Our leftmost would be -8, and our rightmost would be 8. Determine the behavior there. So looking at we have x subtract 8 over x plus 8. The multiplicity of both of them would be 1, so it's going to cross at both of those. So why did I do that there? So it's going to approach infinity on one side and negative infinity on the other. It approaches infinity on one side of that, negative infinity on the other. So at -8 and 8. Determine the horizontal asymptotes if one exists. So we have to find the degree of the numerator and the denominator. The degree of our numerator, our equation was to the 4th power. Thought I wrote it down somewhere. I mean, that's it when I was solving. So our numerator is 4 and our denominator is 2. So numerator 4, denominator 2. So our numerator, and this would be our greater than or equal to n plus 2 option. And if we pulled that to look at it, none. So we don't have a horizontal or oblique asymptote. So that makes it nice for these next ones. There is none. There is none. And then this one is the question over where does it intersect? Well, there is none. So we'll keep up with that. And then we're going to go ahead and do those intervals again. So our intervals on this one, we have negative infinity to that asymptote -8. Then we have from -8 to the other asymptote 8, since there's not an x-intercept. And then we have 8 to infinity. So let's do -10, 0, and +10. And we have x to the 4th plus x squared plus 5 over x squared subtract 64. -10 to the 4th power plus -10 squared plus 5 over -10 squared subtract 64. The top is positive because once I go to the 4th power, the 2nd power, the negatives are gone. And then we have 100 subtract 64, which would be positive, so that's above. Then here we have 0 to the 4th power plus 0 squared plus 5 over 0 squared subtract 64. So that would be 5 over -64. So it's negative, so it would be below. Then 10 to the 4th plus 10 squared plus 5 over 10 squared subtract 64. Top is positive, the bottom would be 100 subtract 64, so it would be positive, so it would be above. So fill them in above and below. So our aboves are negative infinity to negative 8, and then 8 to infinity, and then below is negative 8 to 8. And if we're looking for the one that's negative infinity to negative 8, 8 to infinity below there, so it would have to be this one. Okay, send me all the questions you have whatsoever on any of this, because it's new and confusing, and I'm not there to help y'all like I usually am, and I honestly am getting really tired of doing these lectures online.